So we're at a temperature of about 152, and it seems to be pretty constant at a hot bath or a hot plate setting of 250, so that's good. I'm going to use the same pipette each time. I'm actually going to use one of these longer 9-inch pipettes to reach into the reaction without burning myself. So what I'd like is I'd like to know where the half milliliter level is. So I take out half a milliliter each time. So what I'm going to do is I'm going to measure half a milliliter of dichloromethane into one of these 10 milliliter graduated cylinders. It's actually really hard to read the numbers down low like that. So I'm going to put 2 milliliters in. And I'm going to take half a milliliter into the pipette. So that's at 1.5 milliliters. I'm going to use a Sharpie to mark the level in the syringe, or in the pipette, I mean, so that I'll know how much I want to remove each time. I'll just use the same pipette every time, and in between uses I can rinse it with a little bit of dichloromethane to make sure that I don't get carryover from one to the next. So we're going to have a full test tube of dichloromethane here as our wash. And then another test tube for waste, and then we'll have our storage test tube to leave that in between runs. Now we got a couple of pipettes over there for getting additional methylene chloride out. So we're stable. We're now about 151, or about 151, so that's good. So I'm going to take my first aliquot before I add the para-toluenesulfonic acid monohydrate, but what I want to do now is sink this down. Take that thermometer out so I don't break it. And we're going to sink this into the sand bath as deep as we can, so that it's close to the bottom of the bath. And crank our, oops, wrong dial, crank that up to about 450 so we get a nice stirring rate. We'll put our thermometer back. Now we'll use the scoop to kind of scoop the sand so that it's got as good a contact as we can get to the surface. So that'll get that boiling. We're at 250 there, we're at about 450. You can even go up to 600. Should be able to handle that stir rate. And what I want to do is I want to take out a time equals 0 aliquot of my mixture to make sure that the material is not reacting in any way before I add the para-toluene sulfonic acid monohydrate. So we'll just pull that out, reach in there and fill that up to about that line, and add that to our test tube. And just do a quick rinse, a little bit of dichloromethane, set that aside for next time. And then each time what we're going to do is vortex that to mix. I didn't really need to do that this time, of course, because there's no para-toluene sulfonic acid in there. So that's my first aliquot. And now I have my timer. So I'm just going to open up this condenser, set it aside briefly, and add the para-toluene sulfonic acid monohydrate. And immediately I add that, I'm going to start my timer. And replace the condenser. And we're back up to the 151, so we seem to be stable. Stirring rate of 600. There's still a little para-toluene sulfonic acid monohydrate that's not dissolving, but it will dissolve fairly quickly. And now I have my pipette at the ready to take my time equals 1 minute aliquot out. 54 seconds. So we're going to reach in there, so grab a pipette, approximately half a milliliter, stick that in there, and then we're going to vortex that. That'll stop the reaction, and then we'll quickly rinse this. A little bit of the dichloromethane so we don't get carryover. And set that aside. So this is our T equals 1 minute. And we're going to take our first few at 2 minute intervals and then go to 5 minute intervals. So we'll have a 3 and a 5, and then we'll go to 5 minute intervals, and then 15 minute intervals after 30 minutes. It's a little unreliable. My thermometer is now up to about 153, so I'm lowering this just a little bit. I did accidentally turn that when I was trying to set up the spinning. You'll see that these two have settled pretty well, so I may not need to centrifuge them. But as the reaction proceeds, it will probably turn color, and it's likely that the later fractions will not settle quite as nicely. In addition to taking out the excess para-toluene sulfonic acid to stop the reaction, this reaction is eliminating water, and so the anhydrous potassium carbonate was also being used to absorb the small amounts of water that are forming in the reaction. You may notice that it's already turning slightly pinkish. and it will continue to turn deeper over time. So we're at 2 minutes and 56. I'm going to go in there and get my time equals 3. And then we'll vortex that. And rinse our pipette. And a half milliliter or so of dichloromethane. Oops. Accidentally squirted that back in. There's not going to be very much carryover, and we don't have to worry too much about that. Alright, so we got a slightly colored solution this time. Probably can't see that. Gradually going more pinkish. I think you'll see that that's a little bit pink now. And we're at 153. The temperature of the solution should be at the approximately 140 degree boiling point of xylene, even though the sand bath says 153. It's not 153 uniformly through the solution. You can see that there's some condensate here as it evaporates. So now we're waiting for our 5-minute data point. I'll move this over here so it's closer and easier to get to. Scoot that back just a little bit so this can be flat. So now we're looking for our 5-minute data point. 4 minutes and 58 seconds. That's a little too much. That'll work. Try to make sure I always get it in the right tube. Vortex that. Give this guy a rinse. Rinse that pipette out nicely with the waste. So we've got time equals 0, 1, 3, and 5, and we have 10, 15, 20, 25, 30, and then 45, 60, 75, 90, 105, and 120. Refill my wash test tube. It's just water. Temperature is almost exactly at 150 now, which is where I want it. So hopefully if I don't touch anything, it'll stay there. You can see that that's turning more colored. Pink has gone to kind of a more orangey red. By the end of the reaction, it will have turned quite dark. Acid-catalyzed dehydrations usually do. Stable temperature, good flow rate. 2.5 minutes to the next data point. You can see that it's a little cloudy, so centrifugation will probably be useful. Mix those a little bit because I'm bored. probably dry by now. That's not dry, because xylene takes a while to evaporate. Turning darker. Pretty distinctly orange-red now. And I got 1 more minute for our 10-minute data point. We're going to be plotting a graph after we get the GC mass spec data, where you plot the concentration or the percentage of the alcohols, 2 different alcohol products that you'll be able to see, and then the percentage of each of the alkene products as they appear. And we'll be able to tell which one's which because the molecular weights are 190 for the alcohols and 172 for the alkenes. So we should see 2 new molecular ion peaks with a molecular ion at 172. Probably as early as the 1 minute data point, we'll be able to see some of that. Another 10 seconds to go. Just lift that out of there and grab a half milliliter or so aliquot. Doesn't have to be exactly half a milliliter each time. Vortex that. Rinse this.